fish notes. We're going to finish up fish, and then we'll move into amphibians a little bit.
Are you watching something or doing notes?
All right, notes. No, we're not going to watch that video now. All right, so we'll talk about a few more adaptations that fish have. Characteristics help them survive, be successful in the water in their lives. Gills is an obvious one. We're talking about fish that live in the water. Fish are able to obtain oxygen from the water using gills. Okay? So gills are an organ for gas exchange. For taking in oxygen and for releasing carbon dioxide. It's how fish breathe.
So if they need air to breathe,
They don't need air to breathe.
oh yeah.
They need water. They get oxygen from the water. And so gills are, these very fine, thin, flexible organs. They're just behind the fish's mouth, on the sides of its body. And the fish takes water in through its mouth, passes that water over these gills, and then out through an opening on the side of the body. And that's how they get oxygen. So the water goes in the mouth, then out that opening over the gills. As it moves past the gills, they're able to absorb oxygen by diffusion. Now some fish can pump water over their gills. Other fish need to be swimming to get the water over their gills, but they need that. And the gills are also covered by sort of a protective layer. It's called the operculum. And if you look at a fish and you see it, when you see them going in and out, that's the covering. Just behind that are their gills. And they're surrounded by blood vessels. You can see here's a person, they're holding, this is the operculum, they're sort of holding open. And these are the layers of gills inside. They're bright red because they are filled with blood vessels to maximize the absorption of oxygen through those gills.
So when you see a fish mouth open, does that mean they're breathing?
Yeah, it's constantly opening because they're bringing water in to pass over their gills.
Oh, okay, that's cool.
And when a fish is out of the water, for most fish, those gills are very fine and they're different layers all separated by water, but when they're out of the water, they all kind of just collapse on each other. There's not the water there to hold them up, and so that's why gills don't work outside of the water. Even though there's more oxygen in the air than the water, the gills don't function in there. They function only in the water. Now there are fish that have adapted to be able to live for longer periods of time out of the water. And one of those we saw yesterday in that video was the mud skipper that could actually, move from place to place over land using its flippers, its fins to sort of walk over the surface. So there are some unique fish that, the flying fish. All right, the swim bladder. The swim bladder is an organ that's found in fish, and I'll make this analogy. It's kind of like if you're swimming in the pool and you have a beach ball. I'm sure you all have done this. You have an inflated beach ball, you try and sink it, that pops up, hits you in the chin. Now imagine if you let about half of the air out. Would it still allow you to float? Yeah. But how would you float?
Like a little. Sort of underwater.
Sort of in between, right?
Yeah.
If you deflated it mostly,
Then it would go underwater.
then it would go underwater. You can take it down to the bottom probably. Well, inside of a fish, they have this organ called the swim bladder that works sort of on the same principle. The fish can put air into this bladder, into this sort of balloon, or they could squeeze the air out of it. And so what is that, how does that help the fish? Abby?
Maintains buoyancy.
Maintains their buoyancy. It allows them to change. Buoyancy is the ability of something to float. So by putting air into or releasing air out of the swim bladder can change how well they float in the water. Also, if you ever have done this, if you're trying to float on your back, if you take a very deep breath, inhale and hold it, you could float really easily. But then if you exhale that air, you start sinking. And again, it's because you inflate your lungs, giving you greater buoyancy, or when you exhale, you deflate your lungs and you sort of sink. Joe?
What crocodiles do, or alligators or something, they swallow rocks so they sink to
Really? Another, so the swim bladder is inside of the fish, but it's connected to the outside so they can put air into it. Here's a story I'll tell you. When I was in college, in undergraduate in Vermont, I took a class in studying fish called ichthyology. And we had to go out on Lake Champlain, which is a big lake, really deep. It's between Vermont and New York. And we went on a fishing boat for research purposes. It's like a boat where you put the net in the water, you sink it down to the bottom, then the electric winches sort of haul it up, and you spill the contents onto the deck of the boat, and you start looking at the fish and do whatever you need to do. And so we're studying all the various fish that we pulled out of the lake. And one of the things that we noticed is that there were a bunch of fish that were dead, first of all, and their mouths were like stuck open, and poking out of their mouths was this sort of bubble.
What?
And what this bubble actually was, their swim bladder. And what happened is that, again, an analogy that you're familiar with, if you swim to the bottom of a 10-foot deep pool, how do your ears feel? Yeah, they hurt. There's a lot of pressure. And the reason they hurt is because all the weight of the water in that pool is pushing down when you're at the bottom, is pushing down and also pushing in on your eardrums. And that pressure makes them hurt. So you can imagine these fish that are 60 or 70 feet down beneath the lake, there's a huge amount of pressure from that water above them. And all of that pressure keeps their swim bladder fairly small, sort of squeezing that swim bladder. But once they start coming to the surface, there's less pressure, and so what happens to the swim bladder? It starts to expand. Now normally if they're just slowly swimming to the surface, they can let the air out as it expands, and then it'll be okay. But if they get brought to the surface too quickly, quicker than they're able to release that air, it can expand and blow up inside of them, crush their organs, and that's what was poking out of their mouth, and that's what had killed them, was the expansion of their swim bladder as they were brought to the surface.
It's like a bubble in your mouth, like,
yeah, Jared?
Do you think if you were to fill up like the swim bladder with helium, the fish would float?
that would
They
be
would float
so cool.
differently than with regular air, but it would be the same function. Joe?
My friend had a betta fish, and it swallowed an air bubble, and it exploded.
Oh, really? Shay?
My favorite fish died. I have a question. So, wait, what? Thanks, Joe.
You're welcome.
Oh my gosh.
All right, I'll give you, while you're thinking, I'll give you another story from when I was in, I did this both in
More bubbles.
college at Vermont, also in graduate school I had to do this. You could also go electrofishing. So when we went electrofishing, you would have to, I put on this backpack, and in the back is a generator, you put gas in it, and it's an electrical generator, and attached to it are these two long white poles, and at the bottom of each is an electrode. And so in electrofishing, what you do is we did it in a lake, we did it in a stream, where you basically would walk up the stream and you have these two poles, and when you press the buttons on them, it sends an electrical current through the water. And so you walk through the river, as you press on this button, what happens is all of the fish don't come near, but they're knocked unconscious, and they all start floating to the surface.
Oh my gosh, why would
And
you
so-
do that?
So usually you have people with you, and as you walk through shocking the fish, they pick them up in the nets, put them in the buckets, and then what you do, why you would do this, is you may need to study, you're studying the fish for some sort of research, you may want to measure them, you may mark them, you may, because after that, they regain consciousness after a few minutes, and you release them back into the water. But it's a way to get a large number of fish that are in a certain area quickly. You can't use that to, like, you can't go say I'm going fishing with my dad to catch some fish for dinner and go with the electrofishing. You have to have a permit to use it, and so and you also have to be careful because every once in a while somebody may reach in the water to get a fish or something, or they might trip and fall in the water and you have to let go of the electrodes immediately because they can get a shock as well. It's not like, so you could change the
Would
current.
they be unconscious?
No, so you could change the current because generally you're getting smaller fish. If you're looking for larger fish, you may turn up the current, but by turning up the current, you may also end up killing smaller fish. So you have to sort of judge that as to how much current you want.
God.
All right, and so one related story that's not really about fish, but
What's that?
about electricity. I was doing, we were building a new room in my house, and I was there, I was putting electrical outlets in. Mr. Arcuri was there helping me. So I was putting in the electrical outlet, which I thought the breaker was turned off in the basement, but it wasn't.
And he
So as I
shot
put it
you?
in, I got shocked, and was like,
Your hair
and guess what Mr. Arcuri was doing?
laughing.
Laughing hysterically.
I was right there, and you were distracted. We were talking about
Yeah.
this. And you guys said about that, and you guys were, you're faking it.
No, he says, ask him what
Why
after
didn't you
class
just like
over.
grab your shoulder? Mr.
What's that?
This kid just like grabbed your
No,
shoulder.
it wasn't like a bad, I didn't get electrocuted, but
What?
I got shocked.
Did your hair stand up?
No, it's just like if you ever,
I got shocked though.
if that happens, it's not like, it's not like in the cartoons where like you show your skeleton and your hair goes up. It's like you feel it and it hurts, but it can be deadly, but it doesn't happen.
Did it like stop you?
Yeah, it's like that. You don't like it. All right, questions quickly. Joe. Maggie. Shay.
I have two things. First, so with the swim bladder, see the fish on the ocean floor, how do they like maintain, like without like?
They just are always, guys, they're always adjusting the amount of air and how filled it is, and so that can change how high and how low they
And
float.
also, my brother did that in the basement of his college house. So his friend was down there with him, but it was like fake. My brother was breaking his friend. So when my brother did that, his other friend was like freaking out, and then my brother goes, "Oh, I'm just faking." So he took his apple he was eating and shoved it in my brother's mouth.
Okay. All right, quickly, Joe.
In the Simpsons movie, Homer has the bug zapper, and Bart's like, I think this is cheating, Dad, and Homer whips the thing out by the cord, and all you see is the whole like all the fish.
Oh yeah.
Yeah.
Same idea. All right, Patrick.
Does it jellyfish have a swim bladder too? Because like I've seen.
They don't
No, they're sort of buoyant because of the central area has sort of air trapped in there. Yeah, Brad.
The same thing happened to my dad's friend. They were rebuilding this guy's house and they were getting so he thought the brake was off, and when he put the screwdriver to screw it in,
Yeah.
all my dad heard was a loud boom. And my friend, the outlet was on the other side of the room, and my dad's friend flew across the room.
Yeah, it can be dangerous. All right, let's keep moving here. Circulatory system. As we talk about each type of vertebrate, we're going to talk about their heart and how their heart is configured. Fish have a pretty simple heart. It's a two-chambered heart. It has one chamber where blood enters, called the atrium. And then another chamber that the blood then goes into to pump the blood out, that's called the ventricle. And as we move on to talk about amphibians and reptiles and birds and mammals, we'll see that the heart has evolved from two chambers to three and a half, or 4 chambers.
Wait, what do you mean?
We'll go over that.
Yeah.
We'll go over that probably tomorrow. All right. Now, if we look at the anatomy of a fish, most of this is labeled, but you're going to add 4 things here. When we talk about animals and we're sort of trying to locate different organs, different parts, we have some words that we use. And I know you guys may have learned some of these in health. What do you call the head end of an organism?
Head end, a cranium.
The head side, no?
Head.
The opposite.
Anterior.
Cranium.
Mary Laura?
Anterior.
Anterior.
Posterior.
And the tail end is the posterior. The back side is dorsal. And the belly side is ventral. Yeah, the dorsal fin is here. It's this fin on the back. Okay, the tail fin of a fish is called its caudal fin. The pectoral fins are the ones up closer to the gills.
What are those two on this?
Those are anal fin. That's an anal fin. This might be an adipose fin or something. This is the gill cover, the operculum that protects the gills that are behind it. So let's then look at the internal anatomy. So again, we have the same sides. So internally in the fish, they have the brain, which is really, it's just an enlargement of the spinal cord. So the brain up here attached to the spinal cord. It's not very large, not that complex.
Does everything has a brain? Have a brain?
Yeah.
No, sponges don't have.
All right, then if we look back here, the swim bladder is sort of throughout the middle of the fish. It connects to the outside as well. It's what's shaded in blue here. That's the swim bladder. Jackson?
How come in like sharks or something you can see like their gills? Everything?
They don't have that operculum, that hard covering out on the outside. Then if we look here, the heart of the fish is located ventrally on the sort of bottom belly side. And the two chambers, the atrium and the ventricle. The atrium to take blood in, the ventricle to pump it out.
Why do they need to pump out blood?
Because the blood gets pumped all throughout their body. To get blood down, to the muscles near the tail, the heart needs to pump that blood there.
Our heart does it.
Yep.
I know, but I thought you meant like out of their body.
No, out into their body. And then the gills are back here. They're behind these blood vessels. And like I said earlier, the gills are lined with a lot of blood vessels to allow them to absorb the maximum amount of oxygen through diffusion. And then in the middle back here, we have the stomach and the small intestine, the digestive organs. And there you have the parts.
Wait, what about the one up?
Oh, those are arteries.
So just write
I don't have it labeled on my side. You can write artery in there.
I will, because I'm special.
All right, so that's fish. We're going to now at least start talking a little bit about, just introduce amphibians. So like we said earlier, or the other day, we're going roughly in the order, we are going in the order of evolution. So fish were the first vertebrates, okay, on the earth, in the oceans. But some groups of fish adapted to be able to move onto land, to spend longer on land. And they have certain adaptations, which we'll talk about, that made that possible. But first off, the word itself, amphibian, it comes from two Greek words, ampha and bios. Now we've talked about this before, biology. What is bio? That prefix means something. Christian? Bi on itself means two, but bio is a different prefix. Jackson?
Body?
Not quite. No? Bio, like biology, like bioengineering or
Animals? Nature?
no, but you're close. It means life. Like biology is the science of studying living things. So ampha means double. So this word itself kind of means double life.
Always right around that general area. It's a circle.
And that makes sense because amphibians, one of the main characteristics is that they can live where?
And water.
In water or in land. They were able to make their way onto land for part of their life. But they all still need to return to the water for what?
Water.
Laying eggs.
Reproduction.
Yes.
To produce
I
offspring.
got that. Wait, is
So if we think about amphibians, we could kind of break them up into three groups.
okay.
Give me an example of an amphibian. A salamander,
Toe.
a toad,
I have a question.
hold on,
Turtle.
no.
Wait, no.
Turtles are reptiles.
Wait, no, over the head.
Frog.
Yes.
So frogs, generally frogs have smooth skin, generally kind of moist. They have longer hind legs, whereas toads have drier skin, bumpy skin with short hind legs. But really, frogs and toads taxonomically are in the same group.
Don't you? Well, what's that?
So there's a question I was going to bring up. Do you get warts if you touch a toad? No, that's not true. That's a fallacy.
Okay.
They have bumpy skin, but they're not warts and they don't cause warts. They may. And then what's our last group that, Joe, what did you say? Yeah, salamanders and newts. They are another group.
Newt. You are a nuisance.
Turn me into a newt.
What?
From a movie.
What's
the next line?
What movie?
I can't tell you. Anybody know the next line?
Wait, what was the
Not tongue. She turned me into a newt.
Peter Pan.
No, not Peter Pan.
The witches.
Yeah, it's about witches, Monty Python, Holy Grail. The next line is I got better.
Is it Harry Potter?
Anyway,
No.
so if you look at some, what?
What is it?
The next line? Or what's it from? Monty Python, Holy Grail.
It's just a flash.
All right, this is what kind of frog is this? Abby? Yeah, poison dart frog. Some amphibians are poisonous. This one is extremely poisonous.
But it's
That-
so
That also explains its color. What is the benefit of bright coloration, Brandon?
Traps.
Well, not quite attracting prey. Hold on. Sarah?
Okay, kind of like a bright colors, I usually poison with like hair.
Yeah, warns off predators so that they're less likely to eat it. The smallest vertebrates are actually a type of amphibian in New Guinea. They're 7 millimeters long. That's how small they are. What is this? Hold on. Toad?
Toady.
And salamander.
Those are poisonous.
All right, question. Jackson's had his hand up a long time. Go ahead.
Yes, I have.
I have a question.
If toads are amphibians, how come they don't, like, you never see them near water? They always-
Well, they do that. It must return to water for reproduction.